everybody. Welcome to the video here for lesson number 1 in our last unit of the year, Unit 9 on circles. So the first couple lessons are going to be us going through and developing the idea of how we can find the equation of a circle, looking at circles on the coordinate plane, and doing a little bit of algebra that goes along with the equation of a circle. So here's an opening exercise that we all should be able to do knowing circles. So we know that a circle is a distance from a point, and that distance is the same in all directions. That's why the radius of a circle is the same. So on the opening exercise, it asks us to, on the coordinates below, sketch a circle with a center at the origin. The origin, if we remember, is the point 0, 0, and a radius of 5. So if I start at 0, 0, and I go up 5, to the right 5, down 5, and to the left 5, I'm going to wind up getting 4 points that we know for sure on this circle. Now, when you're in class, I would be saying, grab a compass and make a perfect circle, and then we would look for some more coordinates that are actually on this circle. I don't know if you could see it on the video, but I have a couple of faint points here. I already found some points that I knew were on the circle, and you'll find out more about why I knew those were on the circle later on in the lesson. But I'm going to use those points to kind of get a good sketch of what the circle looks like. So if I just go up here, pass through those points, I'm going to get a pretty good sketch of this circle. Again, having a compass would be a very useful tool here, so if you have one at home, use it. If you don't, just try and not make it look like an egg would be great. So we have our circle. It says name 4 points that lie on the circumference of the circle. We know them, right? It is the point 0, 5, 5, 0, 0, negative 5, and negative 5, 0. Those are the 4 points that we got just by knowing that the radius of the circle was 5. It then says plot the point 3, 4 on the coordinate above. 3, 4 is right here, point A. It's one of those points that I kind of made little faint dots for. It says using your sketch above, do you think point A would lie on the circumference of the circle? The answer is yes, because it looks to be on the circle. Pretty simple explanation. Then it says, how can we prove this? So if I wanted to prove this, I would need to show that this distance from 0, 0 to 3, 4 is 5. Well, I know how to find distances. We know how to find the distance of a line segment using the distance formula. So what I'm looking for is the point 0, 0 and the point 3, 4. What's the distance? If that distance is 5, then I know that this point is on the circle because the radius is supposed to be 5. So the distance formula says to take the square root of the difference of the x values squared and the difference of the y values squared. So if we do some quick calculating in our calculator, 3 minus 0 squared plus 4 minus 0 squared, well, that comes out to be 25. And we all know that the square root of 25 is just 5, so we can say, yes, point A is on the circle, because OA equals 5. And we know that the radius of a circle is going to have to be 5 because that's the radius that they told us. Now, we can use this idea and develop it a little bit more. So we're going to use the idea of the distance formula to be able to show and prove where the circle equation comes from. So in exercise 1, we have a very similar question. So in exercise 1, I've given you a partially drawn circle. So I have the x and y axis drawn for us. I have a circle, and it gives us this random point xy that's on the circle. I don't know the coordinate of it. I made it in a position where you can't even count the boxes. It's a decimal, right? But we do know that xy is somewhere on the circle, and it says that the radius of the circle is 10. So what do we know about every point that lies on the circle? So every point that lies on the circle has a distance of 10 to the center. So even though I don't know the coordinate of xy, I do know that this distance between the center and xy has to be 10. So then it says, show that the point 6, 8 is on the circle. So I know you can count boxes. So if you go 6, 8, you're right here. So here's the point 6, 8. But I want to show that it's on the circle. So I want to show that the distance between the center and the point 6, 8 gives us a value of 10. So I'm going to do basically what I did in the opening exercise. I'm going to subtract the x values of the point and the center, and subtract the y values of the point and the center, and square them, right? Because I'm trying to find the distance from 0, 0 to 6, 8. I want to see that this distance is also 10. So if I do some quick calculating, I get 100 underneath my square root. And the square root of 100 we know is now 10. This is showing that this point is on the circle because it has the same radius of the circle. Is the point 4, 9 on the circle? Why or why not? So I could do the same thing. If I look at 4, 9, I'm not really sure. That's close. Doesn't look like it's on the circle, but we'll see. So if I find the distance between 0, 0 and 4, 9, right, I can see if that distance is 10 or not. So I can subtract the x values and subtract the y values. Well, if I do that, I'm going to get the square root of 97. The square root of 97 is not 10, so 4, 9 is not on the circle. Now, one of the things that I'm hoping that you notice from the opening exercise and from exercise 1 is every single time we tried to find the distance when the center of the circle was the origin, we took the coordinate of the x and the y value and we subtracted 0. Well, anytime we subtract 0, it's basically like I'm subtracting nothing, so I don't even have to worry about that. Like for this example, part B, I could have just done 6 squared plus 8 squared. I still would have got a 100. So if I wanted to come up with an equation of a circle centered at the origin, I could just say square the x values and square the y values. Now, notice it's in a square root. I don't want a square root. So now I could think algebraically, how could I get rid of a square root? Well, I could just square both sides. So I could then just say this is radius squared. Distance really represents the radius of the circle. If you understood what I just explained, awesome for you. Give yourself a pat on the back. If you did it and you're like, I don't know where the heck he just came up with this equation, it doesn't matter. As long as you know this equation, you are good to go. So this equation has a point xy, that's any point that's on the circle, and a radius, which is just r. So if I know the point on the circle, I can determine whether or not we know the value for the radius. I can find the point on the circle. If I know the radius, I kind of can do a lot of things with this equation. So here's a couple like regions type questions. So it says the point 5, negative 12 lies on a circle centered at the origin. As soon as I see these words, I'm thinking this equation. It says determine the equation of the circle and state its radius. So if I square the x value and square the y value that I was given, that should equal the radius squared. So if I do a couple quick calculations, I should be able to determine the radius. So 5 squared is 25, 12 squared is 144, 25 plus 144 is 169. And if I want to know just the radius, I would square root both sides, so I'd be able to say the radius of this circle is 13. Now it also wants us to state the equation of the circle. So when I'm showing an equation of something, I want x and y to be variables. I don't want them to be the numbers 5 and negative 12. That only shows me one particular location of this circle's radius. So I want to be able to find an equation that represents all of the possible locations of the endpoint of the radius. So I would say x squared plus y squared. Now the thing that's going to be true for all points on the circle is the radius is going to be 13. So if I plug in r of 13, I then can clean that formula up a little bit. And here's my equation of the circle. That represents every single point that is or is not on this circle. So if I wanted to see if another point was on this circle, all I have to do is plug the x and y values into what I just boxed in and see if it gives me 169 equals 169. If it doesn't, then that point's not on the circle. So if I take this new coordinate in part B, -3, +14, and I square that x value and square that y value, if that gives me 169, that point is on the circle. If it doesn't, then it's not on the circle. So if I do 3 squared, that's 9. 14 squared, that's 196. And if I add those two things, I get 205 is not equal to 169. So I can say the point -3, 14 is not on this circle. So if I was to graph this circle with a center at 0, 0 and a radius of 13, -3, 14 would not lie on that circle that I drew. Now, unfortunately, not all circles are centered at the origin. And to be honest with you, if you saw a circle equation on a Regents exam, a test, or a problem set that I give you, it's not going to be centered at the origin. Those are almost too easy. So we have to develop another idea. What happens if we have this point that is not at the center? How does that change my equation? Right? So it says, sketch a circle described above and mark an arbitrary point at x, y. So we have a circle centered at the point 3, 2. I have a circle that's going to be around that. And I'm going to make an arbitrary point somewhere on this circle and call it xy. And this distance is going to be 6, because that's the radius of the circle. Now we have a formula for distance. The distance is equal to the difference of the x value squared plus the difference of the y value squared, all underneath a square root. So I can determine the value of xy. So if I do that, I can take this equation and say, all right, the distance, 6, is equal to the square root of the difference of the x values, x minus 3 squared, and the difference of the y values, y minus 2 squared. Now, this is a good equation. It has an x and a y value to represent all points on the circle, because this point we arbitrarily picked. It could have been anywhere. But it doesn't look nice. That square root just makes it look more challenging. So then in part B, we're going to be able to say, all right, let's use this distance formula and write an actual equation of this circle. So what I could do is I could just square both sides. And I can say I have x minus 3 squared plus y minus 2 squared equals 36. Now, this is my equation of the circle. Looks kind of crazy, but there's a lot of things that make this formula easy. We'll notice two things I'm hoping. So the first thing I'm noticing is this is the x value of the center. This is the y value of the center, right? The center here was 3, 2, so I have 3 and 2. And this 36 represents the radius squared. So if the radius is 6, if I square 6, I get 36. So essentially, if I see an equation of a circle in this form, I already know the center. I already know the radius just by looking at the equation, maybe doing a couple quick calculations. So this is the other equation of a circle that we'll use. And this equation of a circle works for any point at the center. So when the center is not 0, 0, we have to use this equation. So this one's going to be a little bit more useful to us. Again, if you understood what we just did in exercise 3, great. If not, just know that you have to know how to use this formula. So let's take a look at a couple questions here. I'm going to do A and B with you, then I'm going to have you pause the video and see if you could try C and D. So for the first one, it says the equation is x squared plus y minus 1 squared equals 81. Well, notice there's nothing added to x, so the center is going to have an x value of 0. Since there's nothing there, it's 0. The y value of the center you might think is -1, but it's not. It's actually going to be +1. It's essentially whatever's opposite of this, right? If you look here, it has -h, and in the center is just +h. Notice these are opposites. The radius of this circle is going to be whatever this number is, but the square root of it, because that is radius squared. The square root of 81 is 9, so we would say that that is just going to have a radius of 9. All right, I'm actually not going to do B. I'm going to do D because it's a little bit different. So let's do D. So D has a X and a Y that have something added or subtracted to it. So I should be able to find the center. So the center of point of this circle is going to be -1, +6. Notice I use the opposite sign for each one. This 72 represents radius squared. So the radius squared is equal to 72. Therefore, the radius is the square root of 72. Well, if I type the square root of 72 into my calculator, I'm going to get 8 point something, which is a totally good answer, but this does say simplest radical form. So we have to try and figure out what perfect square goes into 72. So I have 1, 4, 9, 16, 25, 36, 49, 64, etc. Remember, I'm trying to find the largest number on this list. 36 works, and it goes in twice. Square root of 36 is 6, so I have 6 square roots of 2. So the radius of this circle is going to be 6 square roots of 2. Parts B and C are very similar to parts A and D that I just did with you. So I'm going to have you pause the video here and try these two on your own. When you come back to the video, you'll see they're done for you. We'll talk through them and hopefully you got the right answer. All right, welcome back to the video. So you'll notice in part B, I came up with a center of 4, 3, and I have a radius of 1. 4, 3 comes from what's added or subtracted to x and y, and the radius is whatever the square root of this number is. This is r squared. Square root of 1 is 1. For part C, the center was -5, 0. Notice there was nothing added to y, so we were able to come up with a 0 there. And then we noticed that the radius is the square root of 40, which is 6 point something. But if we simplify the square root using what we learned in previous units, we wind up getting an answer there of 2 square roots of 10. All right, let's take a look at number 5. So if we were in class, I'd say turn to your partner, read through the problem, and just come up with a plan. What would you do if you had this example in front of you and you had to do it if I wasn't there as your teacher, right? So take a minute here, pause the video, and see what you would think to come up with as a plan. We'll talk through it either way, all right, but I want to see if you can come up with a plan yourself. All right, so welcome back to the video. So we have this circle, right? So first thing I'm going to do is I'm just going to draw a quick picture here. So I have a circle, I have a point of 2, 6, and I have a point of 10, 12. This represents the endpoints of the diameter, so the center is going to be somewhere in between those two. So here's my plan. First, I'm going to find the center by finding the midpoint of AB. The midpoint of AB, whatever it is going to wind up being the center. The second step, I'm going to find the distance between that new center that we found in part 1 and one of these 2 points. It doesn't matter which one because both of them represent the same value. So we'll say point B. This will wind up being the radius of the circle. So we're using the midpoint formula that we learned in the last chapter. We're using the distance formula that we learned in the last chapter to come up with this equation. So let's first find the midpoint. So the midpoint we get from adding the x values, 2 plus 10 divided by 2, and adding the y values, 6 plus 12 divided by 2. So the midpoint of AB is going to be the coordinate 6, 9. This winds up being the center of the circle. Then I want to find the distance. I want to find the distance between 0.69 and the point 912. So if we find the distance here, we wind up having subtract the x values, so 10 minus 6 squared, and 12 minus 9 squared. Subtract those y values. So the distance is going to be the square root of whatever this comes out to be when I type it in the calculator. So that's going to wind up being 25. So the distance is just 5. This is the radius of the circle. So if I have the radius of the circle and I have the center of the circle, I can find the equation of this circle. So the equation of a circle is x minus h squared plus y minus k squared equals the radius squared. H and k are the points of the center. So h is 6, k is 9. So I'm going to say x minus 6 squared, y minus 9 squared equals the radius squared. So if the radius is 5 squared, well, that's going to be 25. There's your equation of the circle. That's a great question. It's testing you on a lot of different things all in one big problem, right? But for today's lesson, we're just being able to develop the idea of, I know the center, I know the radius, what's the equation? All right, so let's look at number 6. So I'm giving you this circle. I noticed that there are a couple points I know for sure on the circle. Looks like this one's on there, looks like this one's on there, this one's on there, and this one's on there. So if I connect these points opposite of each other, and connect these 2 points that are opposites of each other, they intersect at the center of this circle. So the center of this circle has a coordinate of 3, -2. The radius of this circle is going to be the distance from this center to any of these 4 points. So if I look, the center to this point to the right is 5 boxes, so the radius is 5. So since I know the center and I know the radius, I can say x minus h squared plus y minus k squared equals the radius squared. So I could say x minus 3 squared plus y plus 2 squared. Notice I'm using a plus 2 here because we want the opposite of whatever that coordinate is equal to 5 squared, which is 25. There's our equation. All right, so this is a good opportunity for you to pause the video, come back, and check out whether or not you did these homework questions correctly. There's only a couple of them, all right? So just take your time there, see how you do, and come back to the video in a couple minutes. All right, so welcome back. So the first question says, what will be the length of the diameter of the circle given here? So for the diameter of the circle, all I really care from this equation is what's the radius. So this represents radius squared. So the radius squared is 121. So the radius is going to be 11. 11 squared makes 121. Since the radius is 11, the diameter is 22, right? The radius and the diameter, the relationship is the diameter is twice of the radius. Number 2 says, which point would not lie on the circle? X squared plus y squared equals 40. This is actually an easier question than you might think. All I'm really asking you to do here is plug in the x value and the y value of each coordinate and see which one does not give you 40. So if I do choice A, right, I would do -2 squared plus 6 squared equals 40. That gives us 40 equals 40, so A is on the circle. Point B, if I do the same thing, right? So if I do the same thing here, I don't want to waste a ton of space, right? I can do -6 squared plus -2 squared equals 40. Type that in my calculator. I get 40 equals 40. That one also works. If I do C, right? If I do C, I wind up doing 6 squared minus 2 squared. That gives me 40 equals 40 also. So C also works. The one that doesn't work is choice D. It always winds up being the last one, right? So if I type in 5 and type in -8, if I do 5 squared plus -8 squared, that's 64 plus 25, so that's 89. That's way bigger than 40, so D is the only one that's not on that circle. If you were confused about number 3, it's exactly the same as number 5 in your notes, just with different coordinates. Follow those steps. So to follow those steps, the first thing I want to do is I want to find the midpoint. The midpoint is going to represent the center of the circle. So -2 plus 6 over 2, and 1 plus 7 over 2. So the midpoint between these two endpoints winds up being the coordinate of 2, 4. This is the center. Then to find the radius, I need to find the distance between this center and one of these 2 points. I'm going to choose this one just because they're positive values. So if I subtract the x value, 6 minus 2 squared, and subtract the y values, 7 minus 4 squared, the distance winds up being, what is this going to be? That's going to be 16 plus 9, so it's going to be 25. So the distance here is 5. This is the radius of the circle. So I know the center, I know the radius, I can write my equation. X minus 2 squared plus y minus 4 squared equals 5 squared, which is 25. Number 4, it gives us 2 different circles and it asks us to sketch them and it asks us how many times did the intersection of the circles happen. So for this, I would say if you have a compass, totally try and use it. It will help for sure. My computer's dying. Let me plug it in. If you don't have a compass, just try your best to try and make good circles if you can. So I'll try my best here because I do not have a compass. So if I go -4, +2, 1, 2, 3, 4, +2, that's my center. The radius of this circle is 5, so I would go up 5, 1, 2, 3, 4, 5, down 5, 1, 2, 3, 4, 5, to the right 5, 1, 2, 3, 4, 5, and to the left 5, 1, 2, 3, 4, 5. Try and draw a nice circle here as best you can. Doesn't have to be perfect, but try your best. This is circle A, so I'll call the center A. For circle B, which I will do with a different color, I have the coordinate of the center of 2, -1, and I have a radius of 6. So I'm going to go up 6, 1, 2, 3, 4, 5, 6. Down 6, 1, 2, 3, 4, 5, 6. I know that the radius is 6 because of the value that it's equal to, right? The radius is equal to the square root of that value. And if I go through and connect our points as best I can, I see that these 2 circles intersect at 2 different locations. So we have 2 points of intersection. Yes, there is a way of actually finding those points of intersection, but we don't need to do that, right? I'm just concerned whether or not you can graph a circle or at least understand what the graph of the circle looks like. Number 5 says to write an equation of a circle with a center of 0, 7 and a diameter of 18. To write the equation of a circle, we never need the diameter, we always need the radius. So if the diameter is 18, the radius is 9. So because the x value is 0, I'm going to have x squared. Since the y value of the center is 7, I'm going to say y minus 7 squared is equal to the radius squared. 9 squared is 81. So there is your equation. Hopefully that all made sense. If you're having trouble, please reach out to me via email. Lesson number 2, we'll talk about how the equation of the circle can actually look a little bit different. All right, but for this, just understanding the difference between those two is going to be important. Hopefully this video helped, and I hope to see you soon.